Hello everyone. So after the naive approach, let's move towards the optimal approach. So in naive approach, we were simply doing three traversals, and what those three traversals were, one was for the path 1 array, another one was for the path 2 array, and the third one was for the path 1 and path 2 array for finding out the common one, means the common element in both of them. But as we were using three traversals, so surely there could be a solution which would be in one or two traversals. Means there is something which could be optimized here. So our optimal solution is now based upon one traversal. Basically, it is also the recursive solution only, the way we were having the previous one. But now it won't be storing anything in a separate array, but it is based on the fact that P1 and P2 both need to be present. If either of them is not present, then this won't work. So that's why we require both of them must in our tree. One more thing is there, this solution is based upon the four facts. That is, either of them is present in same subtree, none of them is present in same subtree, both of them present in same subtree, and the last one will be both of them are present in same line. So for illustrating these acts, we'll simply draw a tree. Let's take the example. We are given with a tree with nodes 10, 20, 30, 50, 70, 60, 80, 90, and 40. So what I was saying was when they are in same line. For example here, 40 and 10, both are in same line. So that's why the lowest common ancestor will be 10 itself. Then another condition was that none of them are in same subtree. So here it's 20 and then 40. Both of them are not in same subtree. So that's why again the LCA will be root. Then the third condition was that both of them are in same subtree. That is 80 and 40. Both are in same subtree. So that's why our LCA would be 60. And the last condition was that either of them are in same subtree. Here 70 and 80 are in different subtrees. So that's why LCA would be this one. So these are the four conditions which were being satisfied. Basically on these four cases it will work, and always these four cases, either of these four cases might be arising. So now let's come up with the solution satisfying these four of the conditions. So here is the code. It is our main function itself. Then if root is not null, if root is not there, then we'll simply return as null. That is, as we are simply recursively calling our nodes, so that's why there would be a condition when our root becomes null, so it will be simply returning null to the previous nodes. So on that condition, if either of the root is equal to the present nodes, then we will simply return the root. That is our example at that is when our example was this one, means this 10, 10 and 40. In this case, when either of them was equal to n1 and n2, so at this case, we will simply return root. That is here, 10 would be returned itself. Then with another condition is, now we will be if both of the conditions were not satisfied, then we'll simply call the left subtree and the right subtree, and we'll pass p and q values to it. So LCA1 will be calling our left subtree, and the LCA2 will be calling our right subtree. And after that, we could check for other three conditions, that is LCA1 and LCA2. Both of them are present. Means when either of them is present in a particular subtree, that is 70 and 80. Either of them are present in a particular subtree. So at that moment, we'll simply return the root. Else we'll simply check for that if LCA1 is present inside left node conditions is satisfied, then we'll simply return LCA1. Else we'll return the LCA2. This is how all the four conditions are satisfied by this solution. And further, its time complexity is again order of n. Basically here n, I'm simply referring to the height of the tree which is fulfilling by these nodes. Like when it's about 40, then the height of the tree will be 4 of this, then it's about only 20. Then the height of the tree will be simply this one, in height of them pertaining to that particular node only. So this was about this.